All right, we're back. We're still on page 181, and we are looking at a plane curve. We're going to use the plane curve to create the graphs of the component functions or just the equations of the component functions. I don't know. And then we'll write the parametric equations. So this is actually a really common thing to do. So what you can do is we're going to create the graphs of the component functions. And then when we have those, we'll write the parametrics. Man, really have to sneeze sometimes these days. Okay. Excuse me. Let's see if we can do this. So, all right. So focus in on one coordinate. And this is the weirdest part about parametrics. Like x is doing its own thing. It doesn't care what y is doing. Y is doing its own thing. It doesn't care what x is doing. But then sometimes they team up and they become a plane curve. And that's kind of a weird idea, but it's what they do. So for example, when I look at just x, I see that first, when t is 0, x is going to be 3. So when t is 0, x is 3. So what am I going to do here? How much space do I have? I'm going to do it here, I guess. So this is my x-axis. And then make this my t-axis, I guess. So this is t. So when t is 0, x is going to be 3. Okay, so when t is 0, x is 3. When t is 25, x is -1. So 25, and then -1. Okay, and then when t is 50, x is back at 3. 50, we're back at 3. And then when t is 75, we're all the way up at 7. Let's say 7, 75, we're up here. And then, I mean, if you had to guess, you would say definitely 100 because t is going by 25s. And when you get to 100, you should have gone t equals 0, 25, 50, 75, 100. So we should be back at 3. All right, if we do all of that, what happens? Well, look at this curve. This should be very familiar. This is a sine curve, and you can see that I did not space it out correctly. So this, in fact, period is 100, so 2 pi over b is 100. So b is pi over 50. And so the sinusoidal axis, we can see is 3. The amplitude you can see is 4. And it's got a negative coefficient because it starts in the middle and goes to a minimum. So this is going to be x equals, I'm going to start with the coefficient. I'm going to say 3 and then -4. It's a sine curve, pi over 50, and then t. I think that'll do it. Now, did we need to do all that work? It's debatable. As you do more of these, you will get more experienced. You can kind of look at the graph and just say, like, this is the middle x value. It's going to go toward the minimum x value, then back up, up, and then back down, right? So it's starting in the middle, going to a minimum. That's a negative sine graph. So it starts in the middle, goes to a minimum. The middle is 3. So that's going to be your sinusoidal axis because that's the middle point that you always get. And then the distance from the middle to the minimum is 4. So it's going to be 3 minus 4 and then sine. Can we think through what's happening with y before we even do it? Let's see if we can do that. So y is starting the biggest it's ever going to be, and then it obviously gets smaller. So which trig function starts at a maximum? It's got to be positive cosine. So it's positive cosine. What's the sinusoidal axis? Well, what's the middle y value? The middle y value is going to be 1. So it's going to be 1 plus, how far are these apart? They're 3 apart. So 1 plus 3 cosine, and then these will be the same. So pi over 50t. So I'm thinking it's going to be 1 plus 3 cosine pi over 50t. Let's actually do the work. So I'm going to switch up my highlighter, just kind of like walk us through this. So when, let's get some axes going though. This will be my y-axis, and then this will be my t-axis. All right, so when t is 0, the y value is 4. And that's the biggest it'll ever be. So I'm going to put it up here. 4 and t is 0. And then we know it's going to be 25, 50, 75, 100. Okay, when t is 25, y is 1. We'll say here. When t is 50, y is -2. So let's put that here. Then when t is 75, we better be back at 1. Let's just confirm that. 75, yep. Back at 1. And then when t is 100, we should be back at 4. And if we go round trip, that's where we end up. All right, so we thought it was going to be 1 plus 3 cosine pi over 50t. And I think that's definitely what we're getting. So you can draw the component graphs. I think it's a really, really good idea. But you can also get them just by thinking. And that's what I do more often than not. And sometimes I have bad habits, so it's up to you. So our parametric equations for this is an ellipse, right? So how do we know it's an ellipse? So x is 3 minus 4 sine pi over 50. I can tell you right now I'm going to end up moving this. So if you're writing it where I'm writing it, you're going to run out of space. Which, you know, me too. So not really a big loss. All right, so I'm going to move this over so that I can, you know, I'm going to move this like right there. I'm going to move this up here and then maybe highlight that so that we know that that's our final answer. Do I have the right size highlighter? Probably not, maybe. I don't know, sometimes I change it up. No, that's right. Okay, that's our final answer. How do I know that's definitely an ellipse? Well, I'm going to use the Pythagorean identity again. Sine squared plus cosine squared equals 1. So what I'll do is I'll take this and I'll say that it's x minus 3 over -4 is sine of pi over 50t. And then this I'm going to say is y minus 1 over 3 is cosine of pi over 50t. So far, so good. Now what we do is we're going to square like both sides of everything. So we're going to go squared, 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 squared. Then we're going to add down. So I guess I'll just keep doing this. And when I do that, I'm going to end up with, if I square x minus 3, I get x minus 3 squared over -4 squared is 16 plus quantity y minus 1 squared over 3 squared is 9. Sine squared plus cosine squared of the same thing is 1. And so this, what am I going to highlight this with? I'll highlight this with this weird color. I mean, it's like gray, I guess. It's definitely an ellipse. It's definitely an ellipse where, so think of your conic sections, right? So x starts at 3 and you go 4 in either direction. 3, and you can go 4 this way, 4 this way. Y starts at 1, and you can go 3 in either direction. Now, I think the parametrics are actually easier to use because the parametrics are explicitly telling you start at 3 and go 4 in either direction. Start at 1 and go 3 in either direction. That's like pretty cool. I mean, when you have parametrics for an ellipse, for a circle, I think for almost all the conics, it's just easier than when you have the rectangular coordinates. But it's totally up to you. I do think, though, that if you are even sort of remotely lost, or if you're not, go back and review notes 5. We did a lot of writing the equations from graphs. And that's, you need that skill. That's like a really important skill. So you might want to go back to notes 5 and review that. I definitely made videos of those. You took the notes, hopefully. Anyway, going to end this page here. I'll be back in the next video to keep going. So I'll see you there.